This is Connor here, and may I present to you the Lalatina line tracker. The goal for Objective 1 was to design and build a robot capable of following the line on the test track. Here you can see the Lalatina line tracker demonstrate this ability at 2 times viewing speed. Lalatina is outfitted with 3 VEX line trackers and 2 VEX 393 DC motors. In addition to the 2 small wheels driven by the motors, there is a third omnidirectional wheel in the back that allows the robot to execute tighter maneuvers. Both driven axles are geared up from the small 36-tooth gears to the medium 60-tooth gears for increased torque and decreased speed. Additionally, the push button on top is used to begin the line tracking process. Objective 2 required Lalatina to count the cross marks and stop after completing 1 circuit of the test track. In the previous objective, the line trackers were used to adjust the direction of travel in order to continue following the line. The line trackers use an infrared sensor to differentiate between lightly colored surfaces and darkly colored surfaces. The values returned by the line trackers can be logically interpreted and used to adjust the motor speed accordingly. With a bit of added logic, the same readings allow Lalatina to recognize and thus count the cross marks. Proper positioning of the line tracker sensors is absolutely necessary. The Lalatina line tracker required several major design changes in order to fulfill the requirements of both objectives. Here you can see the initial fabrication starting with one of the drive components. Although the wheels would change, the gearing would remain the same throughout the project. The main frame is comprised of 2 drive components connected by the centerpiece and the omnidirectional wheel axle. The second level was added using standoffs to raise the platform pieces above the gears, and it was to this that the Arduino Mega Custom was mounted. The battery was secured on the centerpiece, and the line trackers were mounted to a span across the front. Here you can begin to see the modifications to the robot as the wheels have been changed and the line trackers lowered in height. The last modification was to reverse the relative front and back of the robot. These modifications were made for several reasons. The wheels and line tracker mounts were changed to get the line trackers closer to the surface of the test track for more accurate readings. The reversal of direction placed the line trackers much closer to the pivot point of the robot, enabling tracking around tight turns. Although flawed, the original design created a strong starting point for improvements. Please see attachments for both the program code and the full component list. I'm Connor White, this is the Lalatina line tracker, and thank you for watching.